Oh, good morning, everybody. Yeah, hopefully I'm feeling better by the time tomorrow rolls around. I don't know. I'll get a COVID test. I don't think so. I think it's just a cold, crummy cold. I'll go see the doctor. Anyway, today is Tuesday, November 16th. And what I want to talk to you today about is the law of sines. The law of sines, okay? So in the book, it kind of gives you what they do as law of sines. Triangle ABC, sine of A over A equals sine of B over B, sine of C over C. Well, I don't really like to do it this way. I like to use a little different approach. I think it's going to be a little bit easier for you guys to see. But before I start, in big, bright highlights, what you need, you need a pair of opposites. What does that mean? And by the way, these are not right triangles. They are not right triangles, so you cannot use like your sine, cosine, and tangent. You can't use the blue stuff up above on the wall. They are not right triangles, so you have to use different formulas. So law of sines, you need a pair of opposites. So first of all, let's just draw a triangle, any triangle, okay? We should draw this triangle here, any triangle, theta, okay? It is not a right triangle. So we start there with theta. So I'm going to have two angles. I'll have theta 1, and I'll have theta 2. Go ahead and draw that out, okay? Theta 1, theta 2. So I've got two different angles, like here, okay? 54 and 85, okay? So I've got two different angles. They're not 90. And what I want to know is also their opposite sides. So if this is theta 1, its opposite side, directly opposite, I'm going to call opposite 1. And theta 2, directly opposite of it, is going to be opposite 2. All right, you got it? So here's how it works. Law of sines is going to be opposite 1 over the sine of theta 1 equals, write this down, opposite 2 over the sine of theta 2. Write that down and I'll show you what I mean, okay? All right. In this example, you have two angles, theta 1, theta 2, okay? So I got theta 1, theta 2. It doesn't really matter which one you call theta 1, theta 2, but theta 1, theta 2. And if you've got this angle, you have its opposite, 54, and you have its opposite. That's what you're looking for, is if you have a pair of opposites. So I have an angle and its opposite side. So then I can also set up the other angle and its opposite side. So I have an 83-degree angle, and I can find its opposite side. We'll call that little c. Okay, it's all about opposites. Okay, I've got side, opposite angle. I have side, opposite angle. So if we set this up, we'll go opposite 1. Opposite 1 would be the 12, the side. The side, 12 divided by the sine, always sine, of its opposite angle. Opposite angle, the sine of 54, will equal opposite 2, which is what I want to find, c over the sine of its opposite angle. Okay, that's all. It's just side over the sine of its opposite angle equals side over the sine of its opposite angle. Now I want to solve for c, of course, so I'm just going to multiply up. This is a number in my calculator. I'm just going to multiply up the sine of 83. I'll put it right there. And I'll go 12 times the sine of 83 divided by the sine of 54 is equal to little c. That's all I did, is multiplied the sine of 83 and brought it right up there. Okay, now in my calculator, I'm just going to do it. Okay, I'm just going to type this in just like it says, 12 times the sine of 83, close the parentheses, divided by sine of 54, close parentheses, and I get an answer, 14.72. Okay, great, that is correct. So that side is 14.72 centimeters. Okay. Now, the law of sines can also be used to find an angle. Okay. I write it like this. with the unknown on top. Same formula, but I'm going to write it upside down. If I want to find the angle, I'm going to write it upside down. Write the sine theta 1 over opposite 1 equals sine theta 2 over opposite 2. The exact same formula, but I just like to write, if I'm looking for the angle, I like to write the angle on top. It's just easier to solve. All right? So if I have to find angle A, I'll let you write that down. If I need angle A, I'm looking for opposites. Angle A, there's its opposite. And I have a pair of opposites here. Here's angle B and its opposite side. So I'm going to write my formula. Okay, my formula is going to be sine of theta 1, sine of 48. There's my angle. Sine of 48 degrees over its opposite side, over 7. Okay, so sine of the angle over its opposite equals sine of theta 2, which I don't know, that's angle A, over its opposite side, which would be 4. Now, I'm looking for sine of A, so I need to solve. I'll multiply up the 4. I'll bring it right there. And we write this as 4 times the sine of 48 degrees over 7 equals sine of A, okay? Now, I'm going to use my calculator, right? I'm going to use my calculator. I'm going to go 4 times sine of 48 over 7. And I will go 4 times the sine of 48 degrees, close the parentheses, divided by 7. And now I get a decimal. And the decimal doesn't surprise me because I'm looking for the angle, right? I'm looking for the angle. I got sine. So what I have is sine of A equals this decimal, 0.4246. That is not the angle. That is not the angle. So what I do, if I want to find the angle, we've learned this before, I learned this yesterday and the day before, we take the sine inverse. If we want the angle, it's sine inverse of that answer, right? If I want the angle, it's always the inverse button, and I get about a 25.1 degree angle. So angle A is about a 25.1 degrees. Okay, how am I doing? Now, let's put that in there, 25.1 degrees. Okay, now it says solve triangle A, so, all right, I need to find a few more things. If I look at the triangle that I have a lot, but I don't have everything. So I still don't know angle C. That's easy. And I don't know the value of what I call a little c, which is this side here, AB. I don't know that. Well, if I have to solve it, I got to find all angles and all sides. I need all angles and all sides. So let's find angle C. Well, angle C is easy, huh? 180 degrees in a triangle. Angle C is easy, 180 in a triangle, minus the sum of these two angles. And I'm just going to put that in my calculator. I'm going 180 minus my 25.1 plus my 48, and I get an answer of about 106.9 for angle C. 106.9. All right, good. I've got angle C. I'm going to put that in my picture because it's going to help me out. Now I need side C. Do not use Pythagorean's theorem. Do not. Don't use a squared plus b squared equals c squared. This is not a right triangle. So you have to use the formula we used up above, the law of sines. Okay, you cannot use Pythagorean's theorem. You're going to have to use the formula we did up above. Okay, so law of sines. Let's find little c. Okay, I like to write down what I don't know first. So I'm going to go C, side C. So I'm doing this opposite, side C over its angle. And then I'll use probably the 7 over the 48. So opposite side C over, so I'm going to go side C. Side C over the sine, I'm using my formula, sine, the sine of its angle, side C, its angle is, the opposite angle is 106.9. So side over the sine of its angle equals, right? I'll probably use these two because those are better numbers. 7 side over the sine of the angle, okay? And again, I'm just going to multiply this up here. We learned this last year, but it was COVID, so, anyway. So multiply that up, because that's just a number. I'll go C is equal to 7 times the sine of 106.9 divided by the sine of 48. Okay, right? We did learn this last year, but my guess is probably nobody remembers. It was COVID. 7 times the sine of 106.9, close that parentheses, divided by sine of 48, and I get an answer about 9. About 9. Okay? Hopefully you can do this. It's all about opposites. Okay, turn the page. I got a little story problem. Okay? So, two lighthouses are 45 miles apart. Both spot a disabled ship at sea. The lighthouses are on the lighthouse on the west. Okay, so I got a lighthouse here in the west. Here's my one lighthouse. Let's see if I can make it look like a lighthouse. Here's my lighthouse. Sure. And here's my shore. Here's my other lighthouse on the east. Okay. Disabled ship at sea. The lighthouse on the west spots the ship at an angle 58 degrees. Okay, so put my ship out here. Here's my ship. Okay. So the lighthouse on the west angle 58 degrees from the shoreline. So that means 58 degrees from the shoreline, 58 degrees. And then the lighthouse from the east spots the ship at a 72 degrees from the shore, right? Now, we need one more piece of information. Okay, they're 45 miles apart, okay? All right, so they're 45 miles apart. I'm going to put that right there, okay? Now, here's the thing. You have to have a pair of opposites. You cannot use law of science unless you have a pair of opposites. Need a pair of opposites. Well, I don't. I don't have a pair of opposites. I don't, and I don't. But I think I can find that angle. So let's find the ship angle. Okay, that's easy. 180 minus the sum of these two angles. All right. All right. Just going to use my calculator. 180 minus parentheses 72 plus 58. I got 50 degrees. Okay, so that's 50 degrees. And now I have my opposites. Okay, so we just need to know how far is ship from each lighthouse. Okay, so let's call this X, and we'll call this Y. Why not? Distance X, distance Y. So let's find X. Opposites. So I'm going to set up X over opposite side over the sine of its opposite angle equals side 45 over the sine of its opposite angle. Okay, and then we're just going to multiply up and solve. So I'm going to go ahead and just multiply my sine of 72 up here to solve for it. So I'm going to go, okay, I'm going to go X is equal to 45 times the sine of 72 divided by the sine of 50. How am I going to do that? Just go ahead, clear. I'm going to go 45 times the sine of 72. Close the parentheses. It'll really mess you up if you don't. Divided by sine of 50. Hopefully you're in the right mode also. I got about 55.87. All right, so I'm going to put that in there. 55.87. Probably miles, right? Yeah, miles. 55.87 miles. And now to find y, do not use Pythagorean theorem. You cannot go a squared plus b squared equals c squared because you don't have a right triangle. So you have to do the same thing again using the law of sine. So I can do that. Let's find y. Okay. Opposites. Y over the sine of 58 equals 45. Opposites. 45 over the sine of 50. And again, I'm going to multiply. To solve for y, I'm going to multiply the sine of 58 up here. I will have y equals 45 times the sine of 58 over 45. Oh, no, over sine of 50. My bad. Sine Sine 50, almost made a mistake, but I didn't. So I use my calculator. 45 times the sine of 58, close the parentheses, divided by sine of 50, and I get an answer of about 49.82. 49.82. I can put that in terms of miles. I can put that in a picture. Okay, so that's what I have. Hopefully I'll be here tomorrow. Hopefully I'll be feeling better. Okay, there they are. So, homework, please do it. If you get done, I suppose you can work on a little bit of a reverse egg drop. Okay, so I will see you hopefully tomorrow. Okay, bye.